Hi, I'm Miss Hall, and this is Lesson 36, Properties of Rational Exponents, Properties of Radicals, Part 2. An expression involving a radical with an index n is in simplest form when these three conditions are met. Condition number 1. No radicands have perfect nth powers as factors other than 1. Okay, radicand is the expression inside the radical. This is the radicand, and n, or the nth root, that is called the index. Okay, so no radicands can have perfect nth powers as factors other than 1. An example of violation of this rule is if you wrote me the square root of 8. That is not in simplest radical form, because there is a perfect square factor of 8, right? That is 4. And so I can write these two factors. Square root of 8 is the same as the square root of 4 times the square root of 2. And the square root of 4 is 2 square root of 2. So that's the progression. This is not in simplest radical form, the square root of 8, but 2 square root of 2 is in simplest radical form. And so you can extend this to like the third root of 50. If there's a perfect cube factor, you would take it out. And we'll see some of this in example 3. Second rule, no radicands can contain fractions. So what we cannot have is we cannot have the square root of, let's say, 3 over 4, 3/4, square root of 3/4. You can't have a fraction as a radicand and consider it simplest form. So what we would do here is we would take the square root of the numerator and the square root of the denominator, and we know the square root of 4, it's 2. So now this is in simplest radical form. Okay, so not this first one. And finally, the third check is no radicals appear in the denominator of a fraction. We cannot have 1 over radical 3 and be in simplest radical form. We would have to rationalize the denominator. That means we take 1 over radical 3. We multiply both the numerator and denominator by radical 3. In essence, we're multiplying it by 1. Radical 3 over radical 3 is 1, which leaves us with radical 3 over 3. And now it is in simplest radical form. Okay, so when we asked for you to write an expression in simplest form, you need to make sure that these three conditions have been met. Now let's go on to example 3, where we are writing each expression in simplest radical form. So we have the cube root of 135. So I'm going to think if there are any factors of 135 that are perfect cubes. So can I write this as the cube root of something times something? And I can, as the cube root of 27 times 5. I could also write this is the same as the cube root of 27 times the cube root of 5. The cube root of 27 is 3, and then I'm left with the cube root of 5. Now I have it in simplest radical form. Next one, we have the 5th root of 7 over the 5th root of 8. We don't want a radical in the denominator. So here I know the 5th root of 32 equals 2. So I'm going to make the denominator look like the 5th root of 32. And to do that, what I'm going to take is we now have the 5th root of 7 over the 5th root of 8, and I can multiply this by the 5th root of 4, right? 8 times 4 is 32, and if I multiply both the numerator and denominator by the 5th root of 4, I'm just multiplying by 1. Now I have the 5th root of 28 over the 5th root of 32. The 5th root of 32 is 2, so I have the 5th root of 28 over 2. Next part of this lesson, for a denominator that is a sum or difference involving square roots, multiplying both the numerator and denominator by the conjugate of the denominator, the expressions a radical b plus c radical d and a radical b minus c radical d are conjugates of each other, where a, b, c, and d are rational numbers. So what we're going to do in example 4 is we're going to write a radical expression in simplest form. And right now, this radical expression has a radical in the denominator. You have 5 plus the square root of 3. So to simplify this, we want to multiply both the numerator and denominator by the conjugate of 5 plus radical 3, which is 5 minus radical 3. 5 minus radical 3. And so now we'll FOIL. The numerator I know is going to be 5 minus radical 3. The denominator, I am going to use the box method to FOIL. 5 times 5 is 25. This is negative 5 radical 3, positive 5 radical 3, negative 3. These expressions, those terms cancel out, and I'm left with 25 minus 3. So I get 5 minus radical 3 over 22. And now I have no radical in the denominator, so I have simplified the expression. Cube root of 104. So let's see if I can find a perfect cube factor of 104. 8 and 13, because, 8 is a perfect cube. The cube root of 8 is 2, and so it's 2 cube root of 13 is in simplest form. Now I have the cube root of 250 over the cube root of 2. I'm going to go back to, I know the cube root of 8, so let me multiply both the numerator and denominator by the cube root of 4, because then I'll end up with the cube root of 8 and the cube root of 1000. Cube root of 8 is 2. The cube root of 1000, well, actually 1000 is a perfect cube of 10, and 10 divided by 2 is 5. So that is the simplified form of the cube root of 250 over the cube root of 2.